multiplication, but we're going to deal with it and then add stuff. So before we do the add stuff part, let's look at some of the types of situations that we could probably deal with right away. So the first example would be multiplying two numbers together, which are both square roots. So you could get two numbers like that, right? The normal strategy is that you put them together and then you simplify the result. Now, you don't always expect to get a nice number like 4, right? Because you could get something like this. Now, what you do is you put them together. So you go 2 times 6. And 2 times 6 gets you 12. And then you look at 12 and you say, can I do anything to simplify it? Because the bottom line, the end of these questions is always going to be simplify the result. So the result right now is square root of 12. Can we do anything with that guy to make him a little bit nicer?
Would it be like 3 times 4?
Yeah. And that becomes a 2, and that stays as a square root of 3. Okay. Are we comfortable with that type of thing, that numbers get simplified? Well, most numbers get simplified. Okay. So that would be a type of multiplication. I think we've seen similar things before. Let's try another one. I believe this is similar to question 3. Square root of 5 and square root of 10. I'm going to skip some lines here. Okay, we're saying 50 with it. I'm going to write it down. Be comfortable with that step now. Okay, I need to figure out a better version of square root of 50. So how are you going to split 50?
25 and 2.
Right. And that's going to split as 5 square root of 2, and we are finished. All right. Okay, let's up the ante a little bit. 2 times square root of 5 square root of 30. The 2 is kind of an orphan. It really doesn't do much. The 2 square roots become 150. Okay, I need a combination for 150 this time. Let's get a little bit bigger, but it should be doable. Now remember, when you do these things, it has to be numbers like 1, 4, 9, 16, 25, 36, 49, 64, 81, or 100, right? It has to come from that list, essentially. So which one of these guys works with 150?
Isn't it 25 and 5?
I believe it's 25 in somebody. Let's find out what it is.
No, it's 125.
Yeah, 25 is good. It's 25 and 6, that's all.
Yeah.
I mean, you don't expect to do every multiplication or division in your head, especially when the numbers get big. So I would be looking at 150, and then I'd be trying some of these guys, and some of them would work and some of them won't, but we stop when we get the biggest one. So I might have tried 9. I know it doesn't work, but can you see that 9 gives a decimal, which means it doesn't work? And so I would try some maybe a bit bigger. I might try 36. That doesn't work. And then if I go the other way and try 25, see, that does work. So, I mean, you've got a limited list. If you keep trying hard enough, eventually you'll get one that works. Now it's going to be 2 times 5 square root of 6s, and that gets you 10 square root of 6s. So how about this fella? don't think we've ever done a traceable, a treble. What's your gut feeling? What do you think I should do as my next line? What should happen over here?
Put them all under the same square root.
Okay, and 3 times 6 times 4 essentially, which I'm not going to risk in my head, comes out to be 72. Well, that's a good start. 72 works. Can you see a combination for 72? Something in this list will work with 72, and try and pick the biggest one that works, because there's 2. Actually, there's 3 that work, I can see. But the biggest one that works is which one?
36 and 2.
Okay, let's check it out. 72 divided by 36, it works, and there's 2 left. It goes 2 times. So that'll get me 6 root 2. So if we're looking at this as a process, the first thing you do is you multiply them all together, right? And then the single number that you've got, you then break it apart, right, to its simplest version. Are we good? Right. We've not been doing too many cube roots, so that we don't get too kind of rusty on them. Here's 2 cube roots being multiplied together. And this is question 7. Now the process is very similar. You multiply these 2 together and you get 125. And if you're really lucky, it'll be a nice answer. And if it's not, then you do what you need to do. Is a cube root of 125 a nice number? Is it, you know, like the square root of 49 or the square of 100, right? They come out really nice. Can you think of what that nice number might be? What the cube root is? Unless you finished. 5 times 5 times 5 gets you 125. So the cube root of 125 is 5. Okay. Let's move up the food chain a little bit more. Question 9. Or at least a version of 9. Square root of 8x multiplied by the square root of 2x cubed. Why? So put a little notes here. Multiply together. So I'm going to take this guy and multiply him by this guy. Now you typically probably wouldn't write this line down, but I'm going to put it, right? You multiply them together. And what do you get? Well, 8 and 2 multiplied together give me 16. And x times an x cubed, when you multiply an x with an x cubed, you get x to the 4. Why? Are we comfortable that when you multiply these 2 fellas, that's what the combined answer is? We good? 8 and 2, 16, and x with an x cubed gets me x4, and the y is still there. Step 2 now. Call this breaking them apart. So I'm going to square root of 16, square root of x to the 4, and the square root of y. So you break them apart. That's essentially what that is. Multiply them together. That's what that is. And then the final, well, almost the final step. Step 3, I'll just call it simplify, in which case it is the last step. Each of these pieces can be, well, some of each of these pieces can be simplified. The square root of 16 is a nice number, but sometimes it's going to be the square root of 50 or the square root of whatever, and you may have to simplify it times. If you want to get the square root of something, don't you find half its power? Remember that? Square root is like half the power. So the square root of x to the 4 gets me x squared. And sometimes, like in this case, you can't do anything to it, so it's still the square root. And in fact, in this question, there isn't any more simplification possible, so we're done. So you multiply them together, then you break them apart, and then you simplify to get to your answer. And here's a more difficult version of that same idea. 5 square root of 7 x cubed y, and it's going to get multiplied by 2 the square root of 21 x y squared. This is not a nice question. This is an ugly question. I can tell, probably could tell yourself looking at it, that this is not going to be a one-liner, right? We've got lots of stuff to do this fellow. Okay, the 5 and the 2 do not have square roots, so they're just like normal multiplication. 5 times 2 gets me 10. Now this is me putting them together. And so I'm not going to do it in one go, although you might be able to. I'm just writing down what I'm going to do, right? That times that inside the square root. And 7 times 21 is a pain in the butt, but I'll do it. 7 times 21 is 147. And x cubed times another x gets me x to the 4. And a y times a y squared gets me y cubed. Okay, that's me done essentially step 1 then. Until you get to this line here, you've completed step 1. Now I'm going to break it apart. So when you do the breaking apart, that's essentially what step 2 is. And the last step is simplify. Okay, you deserve a prize if you can come up with this. 147 is actually doable. One of these numbers here, one of the perfect squares, works with 147.
Is it 7 and 21?
Well, 7 and 21 do multiply together to give you that, but we must use a number from here. And 7 and 21 are not in this list, so I can't use it. But you're right, 7 times 21 does give you this.
It's 49 and 3.
What do you think, Sarah? 49 and 3?
Yeah.
Yeah, just a different combination of the guys you used. Right. Okay, let's look at, I think the square root of x to the 4 is probably going to be pretty easy. Would you agree half its power, you just get x squared? I don't think it's going to be so easy to do this, fella, but hopefully you've seen enough of them, you can remember it. What do you get when you do the square root of y cubed?
Y square root y.
Yeah. You remember that, guy? When it's odd powers like cubed and 5, you get a bit and then a bit left over, right? So it's 1.5, 1 and a bit left over is a better way to say it. And the bit left over gives you the square root. So we should be able to do this 10. Oops. Sorry about the funny shape there. 7. Square root of 3. X squared. Y square root of y. I'll turn that into a times, I guess. Okay, tidying up time. 10 and 7 get me 70. And an x squared. And a 3 and a y. Oh, forgot a y. And a 3 and a y. And that ugly guy is the answer. So that's step 3 here.
So a light bulb definitely just went off in my head about the y and the y cubed or squared.
Uh-huh.
But if it was like y to the 5th, would you? How would you do that?
Let's look at it. Right. This question's finished. I would think to myself, okay, you're going to half the power. Right. If you half 5, don't you get 2 and a bit left over? So 2 and a bit left over.
Okay.
So if I went and said to you x to the 7, the square root of x to the 7, okay, half of 7 gets you 3 and a bit left over. 3 and a bit left over. Of course, if you're really lucky, you get something like x to the 10. Because the square root of x to the 10, well, divide 10 by 5, divide 10 by 2, you get exactly 5 with nothing left over. So you can see sometimes you get square roots left over and sometimes you don't. Doesn't it really depend if it's odd or even powers? Does that make sense?
Yeah, that actually helps a lot because all the ones that I was getting wrong was the odd powers. So that will help me go back and figure them out now.
Right. So all you need to do is remember the bit that's left over.
Yeah.
Probably that's what was missing. Cool. I like light bulbs going off. I think it's a good point to pause and give you a couple to try, right, guys? I think we should get by with 3. So how about square root of 8 times square root of 6? And for the second question, square root of 8x, we'll make it an xy, that's better, and a square root of 2 xy cubed. And then a really ugly one to finish. Okay, guys, there's 3 questions. Give you 4 minutes. And then we'll check them out. Let's go. Okay, the first one, 8 times 6 multiplied together gets you 48. Okay, how are you going to split 48?
Sixteen and 3.
And that's going to get you 4 square root of 3. So hopefully you got 4 square root of 3 for the first one. So far, so good? Right. Multiply these two guys together, you're going to get a 16. You're going to get an x squared, and you're going to a y to the 4. And you split these up, you get a square root of 16, followed by a square root of x squared, followed by a square root of y to the 4. And this is like one of those amazing ones where the answer is really, really nice. Because doesn't each one of those come out really nicely? The square root of 16 gets me a 4. The square root of x squared just gets me an x. And the square root of y to the 4 gets me y squared. Half of 2 gets me 1. Half of 4 gets me exactly 2. That is our answer. Well, this one ended up really nice. This one is the exact opposite. This one is really ugly. Right. So 2 times 3 gets me the 6. And this guy times that guy. Let's see what we get. Well, at least the numbers came out nice. That's 100. And if you multiply the x's together, you get x cubed. And if you multiply the y's together, you get y to the 7. So far, so good. Now, split them apart. Square root of 100.
10.
Yeah. So 6 times 10 is 60, right? I'll save me some time. Okay. Square root of x cubed.
X square root X.
Got that one
3.
right finally.
Yeah, get it. Yeah. Once you get it, it gets easier because every power in the world is really just basically half it, right? And if there's a bit left over, you get a square root, and if it's a perfect thing, you don't. So when you do half of 7, you get 3 and a bit left over. You get 3 and a bit left over, right? That's how you get the square root of y to the 7, right? Divide it by 2, 3 and a bit left over, y cubed. The last bit is really just tidying up. So hopefully you got that guy. 60xy cubed, square root of xy. Are we good with these questions? You feel comfortable with them? Right, last chance. Right. So now I'm going to show you a guy that you know, or you've met before. And we're going to be using this rule. It's called the distributive law. And I'm not doing it with square roots. I just want to show you what it looks like. Do you remember algebra questions where you had to multiply, in this case, 2x plus 7 by 3? And the way that you did it was called the distributive law. Essentially, this 3 multiplies each of these terms. So you go 3 times 2x, right? 3 times 2x, which is 6x. And then you go 3 times plus 7, and 3 times plus 7 is 21. Can you remember doing that algebra process where you take something and then some brackets and you multiply them, right? You probably did it before you did FOIL, right? FOIL's just a bigger, uglier version of the same essential process. Well, we are going to use the distributive law with square roots. Try to think of a nice example here. So we're being asked to simplify this multiplication. It's the square root of 2, some brackets, and these two guys added. And the way it's going to work is you're going to do the distributive law on it. So it's going to be the square root of 2 times the square root of 8 plus the square root of 2 times the square root of 50. That seem reasonable? Distributive law, same rule. The thing inside the brackets gets multiplied by square root of 2. Now these two guys combine to give you 2 times 8, which is 16. And these two guys combine, and 2 times 50 gets you 100. And this guy is a perfect 4, and this guy is a perfect 10. And so what we got is the amazing answer. I think it's amazing that that ugly expression here is actually the number 14. So things can look nicer if you multiply them out. Let's look at one that's not going to end up anywhere near as nice, but it's a start. This one is like question 13. 6 square root of 2 and 4 take away square root of 2. Distributive law says multiply these and these together. So it's going to be 6 square root of 2 times the number 4. Take away 6 square root of 2 times the square root of 2. In this case here, we've got numbers and one single square root, so there's not an awful lot going to happen here except the 6 times the 4, and I'm going to have 24 square root of 2's. When you multiply 2 or more things together, you know you can switch the order that you do the multiplication. So I just said 6 times 4 times square root of 2, and that's where that came from. Right, 6 times 4 is that, and then square root of 2. Now this fella here, can you multiply these square roots together? Sure you can. But what do you get? Well, you get the square root of 4. Oh, wait a minute. The square root of 4 is a nice number, isn't it? It's 2. So what do you get? You get 6 times 2. So you get 24 square root of 2, take away 12. Right, it might not be as pretty as that answer, but it's a little bit nicer. Let's do something even uglier. This one is like 15. Oh yeah, this is kind of at the tail end of ugliness, right? It's about as ugly as you can make one of these distributive law questions. So I'm going to take this guy, including the negative, and multiplying it by this fella. And this same guy, doing it times that one. I'm not even going to try and do it in my head. I'm just going to write down what it is. So negative 4 square root of 2 times 2 square root of 5. Negative 4 square root of 2 times negative 8 square root of 3. Well, 2 negatives make it a plus. So it's going to be that guy times that guy. The numbers can go together and the 2 square roots go together. The numbers go together and the 2 square roots go together. Can you do anything to the square root of 10 to make it nicer? Here's our list of candidates. Can you do anything that's going to help the square root of 10? No, that's it. It's finished. What about square root of 6? Could we do anything to make the square root of 6 nicer? No. So it's kind of slightly unsatisfying. You would hope it would go further, but not this time. What's wrong with my paper today? It's curling up. The dog just came in there with his toy in his mouth wanting to play. He does not understand working at home. He has not got a concept in his head. He just thinks I'm ignoring him. Okay. That's, I hope, is that enough of the distributive law, or do you want to see more? We're good, okay. So the next fellow we're going to look at, actually the last fellow we're going to look at, it's called FOIL. Can you remember first, outer, inner, and last? Remember a little mnemonic to help you do it. I'm going to do it with just algebra. Right. So this is not directly connected to what we're doing, but we are going to use it. When we say first, wait a minute, let me start again. We've got tons of time. First, outer, inner, last. First, outer, inner, and last. That's what FOIL stands for. Right, now I'll do that guy. So we're going to do an x plus 3, take away an x minus 2. So according to FOIL, the guy that's called first, oops, is this guy. The first in each set of brackets. So in this case, x times x, so you get x squared. And then the guy called O, the outer, these two guys on the outside. Right, these are like the first, these two guys are on the outside. And x times negative 2 gives me negative 2x. Okay. The next two guys are going to be the inner, and the inner are called these two guys. So that's I. Right, the two guys inside the inner. And 3 times x in this case gets me positive 3x. And then last, these two guys, the last one in each, the plus 3 and the negative 2. And in this particular one, these two combine to give me a plus x, and that would be our answer. That's how FOIL works, right? The first, the outer, the inner, and the last. We are going to use FOIL with questions that look like this. So first guy, which one? 16. Square root of 3, add 1. Square root of 3, take away 4. So if you see two sets of brackets, I think Americans call them parentheses, I call them brackets. Two sets of brackets. You know you're going to do FOIL. So it's going to be first, outer, inner, and last. F, O, I, and L. the square root of 3 times the square root of 3. That was the first. The square root of 3 times -4. Right, so it's a square root of 3 times the number -4. That's the O. The 1 times the square root of 3. That's the inner. And the last is a 1 times the -4. First, outer, inner, and last. Right, the square root of 3 times the square root of 3 gets me square root of 9. That guy there just gets me -4 square root of 3's. That guy there just gives me 1 square root of 3. And these two guys then give me -4. Anything we can do about the square root of 9 that might help us?
Make it a 3.
Okay. Would you agree that these two guys in the middle are like terms, so you can collect like terms together? So what do I have? I have -4 square root of 3's plus 1 square root of 3. So how many square root of 3's do you get when you combine these like terms?
Two of them.
Well, you get -4 of them, and then you're adding just 1 of them. So what would you get?
-3.
So you get -3 of them. Okay, anything else that we can combine together?
The 4 and the -4.
Right, so this guy here with this guy here. Okay, so if you take a 3 and a -4 and you put them together, are you comfortable? You get -1. And that fella there is your answer. So in a question like this, you have to do FOIL. You have to multiply things together, right? You have to collect like terms and simplify, and then at the end of the day, you're left with something that looks a lot nicer, perhaps, than what we started with. How about this fella? Okay. It's going to be FOIL again. There's your first. There's your outer. There's your inner. And there's your last. I won't be doing all of this. Right, square root of 5 times square root of 5. I will write them down so I could do that in my head. A square root of 5 times this guy gets you negative the square root of 5 times square root of 3. Going this way, you've got a positive square root of 3 times square root of 5. And then to finish with, a positive square root of 3 times a negative square root of 3 gets you a negative square root of 3 times square root of 3. Now, I could easily have combined this line with the next line. Wouldn't that be the square root of 25? Take away the square root of 15, add the square root of 15, take away the square root of 9. So you could have gone from this line to that line, right? You may be saying in your head what you were doing, square root of 5 times square root of 5, but only write down what you got, right? The square root of 25, rather than actually writing it down in the answer. But that's up to you, what you feel comfortable with. Now, there should be some really interesting things going on in this question. Can you see some of the things that are going on? Square root of 25 is quite nice, isn't it? Square root of 25, what's it equal to?
5.
Yeah. Is there anybody else in this list that good stuff could happen to? Things that make it nicer?
The -9 squared, or square root.
Right, what would the negative square root of 9 become then?
-3.
Right. Is there anything else nice going on? Look at these two guys.
Would those two cancel out?
Totally. A negative square root of 15 plus a square root of 15. It's like negative 2 plus 2, right? They cancel it. So all we've got is 5, take away 3, and there's an amazing answer. That thing there is worth 2. Right? This guy times that guy, right? Using FOIL actually ends up being, doesn't even have a square root in the answer in this particular question. It's kind of interesting, right? This fella is aversion equation 17. We're almost finished this section. A couple of horrible ones to finish, and that's us. 2 square root of 2 plus 1, and a square root of 2 take away 1. So it's going to be first, outer, inner, and last. So 2 square root of 2 times square root of 2. 2 square root of 2 times negative 1 just gets you that guy. 1 times square root of 2 gets you that guy. And plus 1 times negative 1 gets me that guy. And I wish I'd done this in my head, but too late now. Wait a minute. Square root of 4 is 2, so 2 2's get me 4. I made a real meal of this one. So that guy at the beginning, after a few extra lines, ends up being 4. These two are what they were, and this guy at the end is what it was. So we're getting there. Anything that you can combine, like terms, maybe something like that, that could make this a little bit nicer looking. Anything here?
Twos?
Okay. Negative 2 root 2 plus a root 2. How many root 2's do you have left when you do that? You know, like minus 2x.
-2?
I was going to say, just think of x as like minus 2x plus an x. You know, think of it like that. You get the similar result. Oh, won't these two numbers get you a 3? And that's that finished. Okay. I'm going to give you a 3 to try. It's the first one. Here's the last one. Okay, you got 4 minutes. Go for it. See how many of those you can do. Top one's distributive. These other two are FOIL. Oh, be nice. There we go. Yeah. It's a good point. Okay. Whoops, is it? There you go. Come on. It's okay. Oh, shush. There you go. Well, that was Bailey, my dog, getting a bit of attention. He growls when you pick him up. I don't know why, because he wants picked up, so go figure. Right, let's get a shot at this guy. I guess I should have left more room. So I'll just do it at the side here. I believe if I did it correctly, the first two come out as really nice. So let's see how nice that ends up being. Doesn't mean it's a brilliant answer, but 8 times 4 gets you 32. 8 times 2 gets you 16. That's really nice. And what about 32? What can you get out of 32? It's not a perfect answer, but it's still very nice. Anybody got an idea? What's 32 going to simplify with?
16 and 2.
Correct. So if you do 16, you end up with 4 root 2. And that's a very nice answer. I think this one's very, very nice. Although be careful with the sign here. So we're going to do a first, an outer, an inner, and a last. Right, the square root of 3 times the square root of 3 gets you the square root of 9. The square root of 3 times positive square root of 7 gets you a positive square root of 21. A negative square root of 7 times a positive square root of 3 gets you a negative square root of 21. And the negative square root of 7 times a positive square root of 7 gives you negative the square root of 49. Oh, there is some really cool stuff going on in this one, isn't there? The square root of 9 is a perfect number, it's 3. And the square root of 49 is a perfect number, so it's take away 7. And don't the two guys in the middle kill each other off? So I don't even have any square root of 21s when I'm finished. And 3 take away 7 gets you -4. So I hope you got -4 for that one. And the final one in the list is going to be this guy. So we're going to have a first, an outer, an inner, and a last. I'm going to take this much slower. 2 square root of 5 times 2 square root of 5. That's going to get me 4 square root of 25s. Two square root of 5 times 2 square root of 3 is the next one. So 2 square root of 5 times 2 square root of 3. That's going to get me 4 square root of 15s. So there's my first, there's my outer. Let's do the inner now. And that's this negative times that positive. So I'm going to get negative square root of 3 times positive square root of 5. And the 3 and the 2 are going to get me 6. So -6 square root of 15. And then last at the end is a -3 square root of 3 plus a 2 square root of 3. And that's going to get me -6. So times there. -6 square root of 9, I believe. Okay. That guy there's 5, so you're going to get 4 times 5, so you're going to get 20. That guy's 3, so you're going to get 6 times 3, so you're going to take away 18. And these two guys in the middle, I'll just rewrite them for a minute. This is the long way of doing it. So we're kind of at this stage, aren't we? Right. The two numbers at the end combine to give me 2, and the 2 square roots in the middle combine to give me -2 square root of 15. Looking good. Hopefully you got, well, hopefully you got all 3, but hopefully you got most of them. And I think this would be a nice point to have a little break, and we'll come back in say 10 minutes. So I'll give you a chance to, I don't know, Alyssa, get a cup of coffee or something, whatever. And I will see you, well, I'll be here anyway. So anybody who stays behind, I'm going to bug them and ask questions because
Can you
I'm
just
nosy.
put your screen back on? I missed after the 2.
Sure. So anybody that stays behind is going to get bugged by me because I'm nosy. Oh, you got your dog, Alyssa. You have a dog break too? What's it called? It's a Shih Tzu.
This is Ellie Mae.
Ellie Mae is a Shih Tzu?
Yeah,
That's
we're getting a new
Vargas.
roof and she's not very happy about the noise.
Oh, people banging. She has to go and tell you about it.
More just hiding from the noise.
Oh, poor thing. So is that the only dog you have? Very cute. Do you like Bailey, our dog?
Yeah.
You
I
know,
like
the
dogs.
minute you ever notice every time I pick him up, he goes into sleep mode. Just clucks his head to the side and decides I'll go to sleep if you can hold on to me for a couple of hours.
Cute. I think our neighbors across the street have a French bulldog named Frank.
Okay.
That's the cutest little thing.
Yeah, I don't know if our street's typical, but in our street, I would say about half the people have dogs. There's a lot of dogs in our street. Some cats as well, but mostly dogs. So I was, are you good now? Can I get this off in? Just for 10 minutes. Right. Okay, there we go. Sean, you're a sci-fi fan, right?
Yeah.
Okay, so do you want to, I'll give you a trivia question, see if you can come up with it, right?
I don't know if I'll do very well, but I'll try.
Okay. What was the order that the movies were actually produced?
Like the actual names.
No, it's just like
'Cause I went
2, 3, 4, 6, 1, 2, that kind of thing.
5, 6, and then 1, 2, 3.
Correct. What came before all 6? This is your next question.
Came before all 6?
Yes.
I don't know.
You could call it story 0.
I'm not sure.
Rogue?
Rogue One.
Yes. Because what happened there at the end of that, they transfer to Leela and all the fun,
Like the plans. Yeah.
yes. So I'm not sure if that's 0 or 3.5. I'm trying to think of in the chronological order of things where that would fall.
I really enjoyed that one.
It was a bit, it was like Hamlet, everybody dies. You know, there weren't too many survivors in that particular show.
I got to go to the Star Wars land right before the pandemic kicked off in Disneyland. That was really cool.
That sounds really cool. Oh, Savannah's bring a pet day. Okay, Savannah, what's your dog called? It's a hairy thing. That's all I can see right now.
This is Pixie.
Go on, Pixie.
She's very food motivated.
What do you mean? If there's food around, Pixie's near?
Yeah.
Yeah. What about you, Sean? You got any pets?
Yeah, I got a couple. I'll see if I can get one. Hold on.
Oh God, it is bring a pet day. Well, okay, Lexi, what you got?
This is Cooper.
And
That is.
Cooper has got some terrier in him.
Yeah, he's rat terrier and a mini beagle mix.
We had a rat terrier. She passed away a couple of months back. Yeah.
He's old. He's 12 now.
Yeah, she got to 14, which for dogs is you get a good run if you can get 14.
Yeah, and this is unrelated, but your background, that's where I'm at right now.
You're there?
Yeah, I
mean, not that you can show me, but I mean, if you looked out your window, would you be able to at least say it's over there, or could you see it?
No, but
It's over there somewhere.
I could drive there right now. I'm living here until the quarantine's lifted, and that's when I'll go back to Washington.
Which quarantine are we talking about? Because where you are, there's a quarantine.
Yeah. When classes are in person again.
Oh, okay. So you get family?
Yeah, I grew up here.
Also, you're staying with mum, dad, uncle, aunt, big sister?
Yeah, I'm staying at my dad's here.
Okay, gotcha. But I keep on asking people questions. Why don't some of you ask me something? I might not answer it, but you can at least be nosy and ask.
Have you ever been to San Francisco?
Never. And I've been to California at a conference once, but I've never been to San Francisco.
Oh, San Francisco is really nice. It's like super nice.
I believe all California is really nice weather. Well, can't say all of it, but a lot of California is nice.
Yeah, the weather here is kind of like in Washington, just specifically in San Francisco because it's so cold.
Oh. I like heat, so I'm not sure I would prefer that. But I went to, try to remember what the place was called now. Oh God, it had a name. It sounds like it was somewhere else. Ontario. So I was in Ontario, California. So go figure, there's a place called Ontario in California.
I've never been there.
There are only a few things I remember. It's in a valley. We got off the aircraft, and we were drove there, and it's inland, it's not on the coast. And what else do I remember? I didn't like the smell, a lot of diesel in the air. Must have been, a bad air day. And there were tons and tons of lemon trees. I remember that. That's about my recollection of California. Because if you ever go to conferences, people think they're really cool. But so when you go to conferences, you spend virtually all your time stuck inside a big room being talked at all the time. And then you have a lunch break, and then they talk to you some more and so on. And then by the time it's finished, the last thing you really want to do is go out. So you just go to bed, and then you get up the next day and you do another day. And then typically the next day you leave. So it's not like you get to do a lot at conference. At least I never assume you get much time. So any other questions? Savannah, is there anything you want to ask me? Nothing. I'm that boring. There's nothing of interest in me. Okay. Jamie Lynn, I'm going to ask you. You any siblings, brothers or sisters?
I have a twin sister.
Twin as in identical twin, or born at this, two different
Fraternal.
eggs? Oh, okay, gotcha.
And then I have a half brother in California and 2 stepsisters and a stepbrother.
Oh. So who are you closest to? Your stepsister? Not your stepsister, your twin sister.
Yeah, my twin sister. She's actually the mall cop here in Silverdale.
Say that again?
She's a mall cop at the mall. So if you see like a short Asian, like
right.
stubby person, then that's my sister. And
do you know how much trouble I would have been in if I had described your sister the way you just described your sister?
A lot.
A lot. My boss would be having the talk with me right now.
It's funny because it's funny how she likes it how I describe her. She thinks it would be funny. So yeah.
Well, I guess siblings can get away with things that you wouldn't necessarily do with other people. Yeah. But there's nothing about me that you want to ask.
Do you have any siblings?
I have tons of siblings. I'm one of 10 children.
110?
Yeah, I'm number 8 in the list. So
you're the oldest? Or no, younger?
There's not the youngest. There was I got a younger brother, and then we had a sister, but she passed away.
Is most of them in Scotland?
Yep, all of them are in Scotland.
Oh, how come you're here? How come you're in?
Because I married an American woman, and the commute was killing me.
Oh, not to lie, I saw this thing where, about freedom, how anywhere else kind of has more freedom than the States.
Oh,
in its own way.
Oh,
kinda.
God.
I don't know.
No, you do not know what no freedom is like. You should try living in some of the places I've been to. America is a gorgeous place. You got more freedom here, although the politicians would love to take it off us, because I think politicians don't like people who think for themselves. It upsets their karma. They much prefer to tell you what to do, because that's what their kind of mental state is. Oh, God, no. Scotland right now, my sister would get fined right now if she went outside her district.
I mean, in certain areas, I know there's countries way more stricter, but I think I'm pointing it at the ones I kind of thought in my head.
Well, maybe.
In its own
my
way.
Experience is different from yours, so that's true. Everyone's valid. You certainly could be right. But
I've been out the country before, and I see like how it is, kind of.
I don't know. I like America. I think it's the most free country in the world I've ever. Well, I've only lived in Britain and America, but I've certainly traveled a lot in Europe, so I can vouch for those places. So any country that can handle me must be a pretty good country. I'd probably be kicked out most other countries by now. But they like me. No idea. It can't be my jokes. We should start with the jokes, shouldn't we? Has anybody, Jamie Lynn, have you got a corny joke? And then we'll get started on our next group of questions.
I saw one. Hold on, I'm trying to think how it went. Oh shoot, I don't remember. Oh, let me think.
Okay, well, she's thinking, did I tell you the one about there's a new Barbie doll out?
No.
You did? Anybody remember the punchline then? Right, there's a new Barbie doll out. It's called the... No? Oh, maybe I haven't told you that. It's called the Divorce Barbie. It comes with Ken's house and Ken's car. That was my Barbie. Jamie, you got your joke?
Yeah, I looked it up so I remember it.
Okay.
Because I saw this outside where I live. It says like, what do you get if you cross a rabbit with an insect?
I don't know. What do you get?
You get Bugs Bunny. You know, like
Oh,
the cartoon?
I got it. I can't beat that one. Do you know Scrabble is all fun and games until you lose an eye?
Oh, that's funny.
Okay, everyone, I think you've suffered enough. Right, let's get this show on the road. What I want to get done now is the next section, which is we are getting there. Division and rationalizing. I think if we get through this will be good for today. Again, it's really just like the equivalent of multiplication. We're going to look at two things being divided and how you can simplify them. And then this fella here is rationalizing the denominator, which we have seen. And that does end up being part of the process. So let's start with how you could simplify a square root of essentially a fraction. And the way that we kind of look at a fraction like this is, and you can look at all fractions in the same way, is that it's really just a division. So the square root of 1/5 is the same thing as the square root of 1 on the top divided by, so it's a division, the square root of 5. Now the square root of 1 is nice, and the square root of 5 is not so nice. And you might think, well, that's it. I've done my bit. We're finished. Well, we're going to use this fella here, rationalizing now. Can you remember that you don't like square roots with square roots in the bottom, right? It's basically just a rule of algebra. And so what we do is you multiply by a special fraction. And this fraction is 1, right? And the special version of 1 is root 5 over root 5. And what that gives us is the square root of 5 on the top and 5 on the bottom. And this process has got a fancy name. Rationalizing, try to figure out how to spell rationalizing the denominator. Can you remember we did some rationalizing the denominator? Can you remember seeing those guys? Let's pick some more fractions. Let's suppose 5/3. That's going to split as the square root of 5 over the square root of 3. And then we'll rationalize the denominator by multiplying by this special version of 1. The reason this works is that according to mathematics, common sense as well, if you multiply something by 1, you don't change its value, you just change how it looks, right? It looks a little different, but it's worth the same amount. The two top guys give me the square root of 15, and the bottom guy gets me 3. And there's our answer. How about square root of 8/6? Okay, any ideas how I might tackle this simple division? I know it's a fraction, but we can call it division because it is. Anything going on there that could help us?
Would you simplify it?
Okay, that sounds like a good plan. Would you agree? That would help. Now, when I split it, I get that guy. So sometimes you have to adapt, right? Now, I'm going to rationalize the denominator in a minute, right? So I'm going to multiply by square root of 3 top and bottom. Agreed? Is there something I could do before that that might make the answer come out even prettier? Can you see anything interesting in this particular fraction stroke division?
Do you want to simplify the 4 to a 2 since it's a
Agreed. And now rationalize the denominator. And that's the answer that we're looking for. And that is pretty much the first 8 questions. So let's pick some ugly versions of that. Right. So in the next section of homework, questions 1 to 8 will all look something like these guys. Right, this particular one is ready to have its, rationalize the denominator. Are we comfortable with the special version of 1 that you use in this question is the square root of 32? Right, whatever that square root there is, that's the one that you're going to use to rationalize the denominator. Now 5 and 32 get me 160. And this guy is 32. So far, so good. Now we've hopefully dealt with square roots enough now to recognize when there's a square root that might be simplified. Looking at the square root of 160, is there a good chance that that's going to simplify? You agree? It's a nice round number. There's probably there is somebody who can work with it. I'm trying to find my piece of paper with all my guys on it. There we go.
32 and 5.
Well, 32 and 5 does give you 160.
Oh, never mind. Just kidding.
Yeah, but you're very close to the right number. If you just look through your list here and pick somebody else that's not 32 and 5, because pick something else, but it has to come, one of them has to be in this list.
16.
Yeah. 16 and 10. So 16, 10, 32. 4 square root of 10, 32. Do you think we're finished now, or is there some mileage in this question still? Is there anything we can simplify a little, just a little bit more?
10.
No, can't see anything really in the 10.
4.
The
Four in the
32.
Yeah, that's the one. You were still thinking of square roots, probably. That's what threw you. Right, would you agree? 4 and 4. So that gets me a square root of 10 over 8. And that's essentially what we're after. Are we good? I'll just give you one to try out, just a single question. This one is similar to question 7. A horrendously big number. Right, go for it. Not going to give you long. I'll give you a minute. God, that's a horrible number. Ugh. I'm sorry I gave you that question, but too late now, you've got it. Now, it is a homework question, so it's something that's going to happen. Okay. The two top numbers give you 896 over 128. I guess this is a good question for one thing. How do you simplify ridiculously big numbers? Well, this is how I would tackle it. Now, if you find a number that works, that's great. If you take 896, just get it smaller. Even if it's not the final answer, at least give it a chance. Right, now it's even. So I'm going to pick a number like maybe 4 or 16, right? Try them out first. So 896 divided by 4, that works. I'm not saying that's the best answer, but it's 4 times 224, which gives me 2 square root of 224 over 128. That cancels down a little bit, and I'm now looking at 224 over 64. Okay, so it's a little bit nicer, right? I'm not saying this is it's definitely not the efficient way of doing it. Has anybody got a number that works with 224? At least that's, reasonable. It's still huge.
I
But
got
at least
64 and 14.
okay, let's do it. 224 divided by 16. Wow, well done. I wouldn't have guessed that. Not off the bat anyway. So we're going to get a 16 times a 14, which is going to get me 4 square root of 14 over 64. They cancel down, and you now get the square root of 14 over 16. It's like simplifying normal fractions. Don't you keep going until you can't do anything else?
There's actually a other number that you can skip that whole 224 and just go straight to.
Oh, that would be cool. What number was it?
It'll be 64 times 14.
Is that what I said? No.
Yeah, that's what she said.
Oh, but then no, but
Oh.
that's the 224, because then
Yeah.
the 224, then you had to go to 16 times 14. But then
Okay.
what since there's
You
the
were saying
800,
64?
yeah, 64
14?
times 14. So that's
Oh,
the one from the
yes.
896, and then I square rooted to 64 times 14.
Oh, that was a cool one. Yeah. That didn't come to my brain, but that's
I
cool.
think that's what I meant. I just looked at the next line because I have 896 and then 16 times 14.
Right, so you had the same you'd done it the same way then. Okay. Actually, that one works as well because that times that. I guess the bottom line here is that won't you eventually get the same answer? Some ways you might do it 2 or 3 steps to get there, and some you might do it in one really big one. Was there something about 64 that made you think 64? Or did you just try one of these and got luckier?
Just keep trying.
Yeah. They're only about, what, 8, 9 numbers to pick. It's not like it's going to take you forever. Yeah, cool. So what is next? Well, we're still on these division fellas. Let's move on to question 9. And all we do now is we introduce variables to the mix. So I have a 27 x squared y over the square root of xy. Now, the minute you do a question that has variables in it, you kind of have to change the process a little bit. I'm going to put the thing back together as a single square root. What do you think I'm going to do next? So I've put this together as a single square root. What do you think I'm going to do to this expression here?
Simplify.
Check the x and y's.
Okay, so what can we do? Cancel an x with one of these, leave an x behind, cancel the y, all gone. It looks like I'm going to be left with just 27x. You see, that's a little bit different, isn't it? When they're both numbers, you kind of go one road. But the minute you start bringing x's, y's, z's, variables into the act, and things kind of get, a little bit different. Okay, I want to make this simpler. There's not an awful lot I can do, but I can do something. I can change the square root of 27. Okay, we got our list over here.
9 and 3.
Okay, and if you do a 9 times 3 version, you're going to get a 3 root 3. And that's actually correct, but I think most people like the square roots to be last. They just look better. In the middle, they look a bit weird to me. So I would write it that order. Are we good? So let me show you one that looks very innocuous, like, there's nothing going on there. And it's devious, this question.
I had a question about the last question.
This one?
Why wouldn't the x be in the square root?
That is a very good question. It should have been in the square root, and I forgot. I made a mistake.
Okay.
look at this guy. If I put it back together, do you see I get nothing out of it? Now, I can't, well, I'll take that back. I could do the 4. Let's make that 14, so I can't do it, right? There's nothing helpful I can get out of that. But nonetheless, we are expected to rationalize the denominator. So what special version of 1 should I use to rationalize the denominator?
X. Square root X.
Agreed? Now the 2 guys in the bottom get you X, and these 2 square roots just combine into that one. Now, I know that doesn't look much better, if anything, compared to the original, but nonetheless, that's considered the simplest answer, right? We don't like square roots on the bottom of fractions. It's just a rule, ain't allowed, don't have them, make them go away. Let's try this fella. This is question 11. And I'll try and make sure that I don't screw up this time. Now, in this question here, I do put them back together again. In this question up here, I didn't. So when you look at this question and you look at this one, you might say, well, how do I know when to put them together again and when do I leave them alone? If the tops and bottom, right, the numerator and the denominator, both contain the same variable. So you see up here, these only have y's and the bottom only has x's. There is no point putting them together. You won't get anything useful. What you have to do is rationalize the denominator. But if the numerator and the denominator have common variables, even if there's only one of them, it's worth doing this too. Now, the 10 and the 2 gets me 5. The x and the x cancel, so they're totally gone. What do I get if I have a y squared on the top being divided by a y cubed on the bottom? What's left over and where does it go, top or bottom?
A Y on the bottom.
Y on the bottom.
You all agree? Y on the bottom. So this is the original. This is what it looks like. What I'm now going to do is break it apart. And the reason I'm breaking it apart is, do you see that we have got a square root of y on the bottom? What do you think I'm going to do with the square root of y to finish this question off?
Multiply
Multiply
it.
top and bottom by y.
Yep. And if you do that, on the top, you will have the square root of 5y, and on the bottom, you'll have a y, and you are finished. The simpler version of this division, because that's essentially 2 things being divided, is this answer. Oh, and by the way, this y and that y don't cancel. Can you see one of them's in a square root and the other isn't? You can't cancel things if they're not similar structure. This is like question 13. Oh, sorry. I was right the first time. Right. In this question, shall I put them together inside a single square root? Agreed. Can you tell why I need to do that? Because all these ABCs in both top and bottom. Okay, tell me anything that can cancel with anything else. I don't care what order, just pick some.
10 to 5 and 2 to 1.
Okay. Right, so we got that one. Anybody else can see something that we can cancel top and
The
bottom?
A's.
A's and B's.
Okay, A's
Never mind.
cancel.
A, B on the bottom, and C on top.
Okay. What's going to happen when I do the C's then? It's the last one. C cubed on the top, C in the bottom. When they cancel, what's going to happen?
There's
C.
going to be just a C squared on top.
Great. Now that's a total dog's dinner. So that's one, that's one, that's one. There's a C squared. That's the only thing on the top that was left alive. And on the bottom, I've got a 5 and a B. Do we agree on that? I'm asking more in the sense that I don't want to screw up. Vanessa, does that look good to you? Okay. I see you nodding, so I could tell you said yes. Now, I'm going to split this. Maybe take more lines than I would choose normally. Can you do anything nice about the square root of C squared?
It'll just be C.
It's just a C. Okay, we're looking at a pretty nice looking answer, except it's got one big sore thumb, right? Sticking out like a sore thumb. Isn't it the square root of 5b on the bottom is the sore thumb? We don't like it. It's ugly. It shouldn't be there. Gotta go. Special version of 1, square root of 5b. I mean, it doesn't need to be the square root of 2 top and bottom, or the square root of b top and bottom. It can be the square root of 5b top and bottom, right? As long as it's the same thing, it's allowed. Now, what we're going to have here is a c square root of 5b, and on the bottom, a 5b. We are at the kind of the tail end here, right? There's not an awful lot more to be expected of you. I want to show you something. This may or may not work, but at least I'll try. Are you all looking at question 14? Oops, I can't see you right now. There's a window in the way. Can you see question 14 concept check? Right. So, if I click on that guy.
In this video, we'll take a look at dividing radical expressions, and to do that, we're going to use the quotient property of square roots, which says that if a and b are positive numbers, then the square root of a over b can be written as the square root of a over the square root of b, okay. And it works in the opposite direction as well.
So what we have here in your homework is a little video, and essentially you watch it, and it's just another way of, you know, I'm a great believer that there's more than one way to do something, or at least one way to say it, another way to say it. Yeah, even doing that wrong. So I like that question because it does give you the ability to maybe see someone else's kind of way of looking at it, right? So to finish today, I'm giving you a massive 5-question chunk of guys to do, and then we'll go over them. And if we're having no problems with them, then I'll feel comfortable that homework 16 is sealed, right? So.
We can't see the question during the time.
Do you mean you'd like to see the questions? That sounds like something you probably should want to see. You're right.
If I can't see it, then I'll just leave.
Uh-oh. Okay, we're not doing that. There's your first one. There's the second one. And I'll make the last one the ugliest one I can think of. Nobody would give you that one, but I'm doing it anyway because I can. Four's enough. I'm not giving you 5. Don't need 5. That one there's going to kill you anyway. Kill me, and I'm looking at it. Okay, you got 5 minutes. See how many of those guys you can beat. You'll be spending most of that 5 minutes on question 4. Okay, let's get this show on the road. When you look at questions 1 and 2, don't they look very similar? Like you might even expect the same answer, but you'll be surprised. Question 1 is ready to have the denominator rationalized. So I'm multiplying top and bottom by root 6. That gets me 3 square root of 6 over 6. And then, because sometimes it happens and sometimes it doesn't, do you see the little cancelling going on? And we get that. And that is the finish. Why am I not allowed to do the 2 into the 6 and call the answer square root of 3? Why is that not allowed? Apart from the fact it's not correct, but why can't you do a 6 divided by 2 in this question?
Because the top is a square root, the bottom isn't.
That's bang on. That's exactly the reason. Because you know, sometimes you have to know when to stop, don't you? Because see, when you're on a roll, don't you want to just keep going? There's this kind of just keep going, but you got to know when to stop. That's finished. This question looks similar. It's got the same kind of numbers, but it's a single square root. So when we rationalize the denominator this time, we end up with the square root of 18 over 6. Okay. Square root of 18. That can simplify. We just have to figure out what 2 numbers to use to get 18. Agreed? What's 18? What 2 numbers?
9 and 2.
If you do square root of 9 times 2, you get 3 square root of 2 over 6. And that might be the end, but it's not in this case. Can you see something that can be done?
3 and 6 could be simplified.
And now we have a square root of 2 over 2, and we're finished. You see how that one worked? If you look at the 2 answers, they're not quite the same, right? Square root of 6 here and the square root of 2 here, right? So they might have looked the same question, but they're not the same answer. Right, this horrible guy. Do I split these 2 guys apart, right? The numerator and denominator. Do I split them apart right now, or do I do something first?
You cancel out some stuff.
Okay, quite a lot of cancelling, isn't there? That guy cancels with a 2. The x on the bottom cancels an x squared on the top and leaves an x left over. And the y cubed on the top cancels with a y, with 4 on the bottom, and that leaves a y behind. So what I've got on the top was 2x, and on the bottom I've got y. So that was a lot of cancelling. I'll now split it. Can you see that we're going to have to rationalize the denominator in this question? Right, I'm going to fix it.
By y on both top and bottom.
Agreed. And on the top, you get a single square root with 2xy in it. And the bottom, you've got a y. And we're finished that one. Okay, just one last question for tonight. Oh, God in Himmel. Sheesh. That's an ugly looking character. Hopefully, did you get to the end? Might not be right. I hope it's right, but did you get to the end? Okay. First thing I'm going to do is just put everything inside a single square root. And then there should be a lot of carnage going on, right? Just chuck anything at me. Something cancels with something. Tell me something that can cancel with something else.
I cut 14 to
14 and
7
8.
and 8.
Okay, we'll do
to
the
4.
14 and 8. So I'm assuming that's going to be 7/4. Right, give me something else.
The A's go away.
Okay. Something else.
B on the bottom.
Okay, those two cancel out and leave a B in the bottom.
C on the top.
C?
Mm-hmm.
Sure.
Yeah, 1 C on the top. Oh, wait. Oh, I wrote it wrong. That's why.
Okay. So a C squared on the top. How
And
about
a
the D's? What's going to be
D
left
on the
over?
bottom.
Great. So a lot of different things. Let's see what's left. There's a 7 left and a C squared on the top. And there's a 4, a B, and a D on the bottom. So now you split it. Ooh, not nice, but at least it's nicer, right? It's still not nice, but it's nicer. Any suggestions what to do next?
Multiply the top and bottom by square root 4 BD.
Sounds like a plan. And that gets me a 4 BD on the bottom. And 7 and 4 gets me, what, 28. And I have a C squared, a B, and a D, right? That's kind of what I've got. And I've noticed one more thing that I can do.
Simplify it.
Yep. Can you see that there's a little bit of simplification left over?
That be with the 4 and the 28, or?
Oh, yeah. That's correct, and I missed that, so you're right. And there's another thing on top of that as well.
The B's and D go away?
Mm-mm. Square roots, not square roots. They don't cancel. But there is something in the top square root.
The C squared?
Yeah. So won't the 28 get you a 4 times 7? So that's basically going to get you a 2 root 7. And won't the C squared get you a C? And won't the B and D still be there? So when you take this guy on the top, you're going to get a 2, a C, a 7, and a B, and a D left over. And that is as good as that's ever going to get. Well done if you got it to that point. Actually, well done if you got it to anywhere kind of from here onwards.